Finding x and y intercepts. To find the x-intercept of a parabola, let y equal 0, then solve for the other variable, that is, solve for x. To find the y-intercept of a parabola, let x equals 0, then solve for the other variable. Solve for y, or if your function is written in function notation, you'd be solving for f of 0. Now here is a very important note. You can have only one y-intercept. So there is exactly one y-intercept for every parabola. But there may be up to 2 x-intercepts. So you will always have one y-intercept, and you may have 0, 1, or 2 x-intercepts. Example 3, finding the x and y intercepts of parabolas. Find the x and y intercepts of y equals x squared minus x minus 6. Check your work using a graphing calculator. So let's start with our x-intercepts. And remember, we may have 0, 1, or 2 of these. So for our x-intercept, let y equal 0. So 0 equals x squared minus x minus 6. Let's factor the right side of this equation. This gives us x minus 3, x plus 2. So x minus 3 equals 0, x plus 2 equals 0. So we have x equals 3, x equals negative 2. The intercept associated with this solution is 3, 0, and the x-intercept associated with this solution is negative 2, 0. Now let's look at our y-intercept. And remember, you'll have exactly one y-intercept. So let's let x equals 0. So we have y equals 0 squared minus 0 minus 6. So we end up with y equals negative 6. The ordered pair that this corresponds to is 0, negative 6. Now let's check our work using a graphing calculator. You're going to want to go to y equals and type in the equation of this parabola. Then hit graph. And to make certain you're in a standard window, you can click the zoom button, and number 6 will get you to a standard window, which means you'll have a minimum x value of negative 10, a maximum x value of positive 10. And similarly for the y values, for y-axis, you'll have a minimum of negative 10, a maximum of positive 10, and each of these little hash mark represents one unit. So let's see what these are visually. 1, 2, that looks like a negative 2. 1, 2, 3, this definitely looks like a positive 3. 1, 2, 3, 4, 5, 6, that looks like a negative 6. So that was a visual inspection. Let's use the tools of our graphing calculator to figure these out, actually to verify these values exactly. Go second and trace button to get into your calc menu. This time go to the number 2 for zeros. Let's start off with this 0, this x-intercept on the left. So find your left bound, so somewhere to the left of this intercept. Find somewhere to the right, and now guess. Negative 2, 0. We have verified that that is indeed our intercept. Let's do this again. Second, trace to get into the calc menu, the number 2. Now let's scroll to the right. This puts us to the left of this rightmost x-intercept. Now let's find our rightmost bound. Make certain you're hitting enter in between all of these steps. And let's find our guess. We have 3, 0. Finally, how are we going to verify this y-intercept? Well, it might be tempting to use the minimum function, the minimum tool on your calculator because it looks like it's right here around the vertex. It's not the vertex of this parabola. So let's go back into our y equals menu. And we think it hits the y-axis at y equals -6. So let's graph this. Y equals -6 as our second equation. Then hit your graph button. Now we can verify that this parabola intersects this line by going to the second button, the trace button, to get into the calc menu, and then the number 5 to get to the intersect. First curve, hit enter, second curve, hit enter, and guess. And our cursor stayed about the same spot each time. 0, -6 is definitely our y-intercept. Let's move on to discussing the quadratic formula. When finding the x-intercepts of a parabola, one that is not easily factorable, use the quadratic formula. The quadratic formula tells us that x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. And this is for a parabola of the form ax squared plus bx plus c. You do need to memorize this. So memorize this formula. Let's look at example 4. Example 4, finding the x and y intercepts of a parabola that is not easily factored. Find the x and y intercepts of this parabola, f of x equals 2x squared plus 4x minus 4. A in this case is 2, b is 4, c is -4. Here's our a value, our b, and our c value. So let's go ahead and plug this into our quadratic formula, which is still visible up here. So I have -4 plus or minus the square root of 4 squared minus 4 times a, which is 2, times c, which is -4. All divided by 2 times 2. So I have -4 plus or minus the square root of 16 minus, well, let's see, this is a negative times a negative, so we'll have a positive. And we have 4 times 2 is 8, times another 4 is 32. So 16 plus 32 divided by 4. So I have -4 plus or minus the square root of 48 divided by 4. Now we need to simplify the square root of 48. If you're at all rusty on this, as an aside, you'll need to review simplifying radical expressions. Let's keep going. This is -4 plus or minus the square root. How can we rewrite 48 so it is the product of a perfect square with another number? That is 16 times 3. Will give us 48. So we have -4 plus or minus the square root of 16 times the square root of 3 divided by 4, which is just equal to -4 plus or minus 4 square root of 3 divided by 4, which is -4 over 4 plus or minus 4 square root 3 over 4. And a lot of you might be thinking, oh, Miss G is showing a lot of extra steps here. Why is she doing that? But there is a good reason. So here's another aside. Actually, let's not call this an aside. Let's call this a warning. I see this happen a lot, and students lose points in my class a lot for these sort of errors. So don't do these. We have -4 plus or minus 4 square root 3 divided by 4. What you do not want to do is this. If you do this, you might think the answer is -1 plus or minus 4 root 3. This is wrong. Also, you do not want to do this. That is also wrong. Neither of these are the correct answer. So don't do these mistakes. Now, I split this up into two fractions to make it clear that this is one fraction and this is another. So this is -4 divided by 4, which is -1, plus or minus. Here I have 4 square root of 3 divided by 4 is just the square root of 3. So my x-intercepts are at -1 plus root 3, comma 0, and at -1 minus root 3, comma 0. And that's all that is meant by the plus or minus, is that we have two answers. We have one with a plus sign in the middle and another with a minus sign in the middle. Next, let's look into finding the y-intercepts. And remember, to find the y-intercept, let x equal 0. So we have f of 0 equals 2 times 0 squared plus 4 times 0 minus 4. So we have 0 plus 0 minus 4. So f of 0 simply equals -4. So our y-intercept is 0, comma -4. Go ahead and turn to the last page of section 3.2 so we can work on example 5. Example 5, find the dimensions of a rectangular garden producing the greatest area enclosed given 200 feet of fencing. So let's start by recalling something from algebra. Recall that your perimeter equals 2 times the length plus 2 times the width, and your area equals length times width, and that would look kind of like this. If this is our width, and here we have our length. These little marks tell me which sides are equal. I have one mark here and one here, so both of these are a W. I have 2 marks and 2 marks, so both of these are an L. Now, what is our perimeter? Well, what do you put around a garden? You put the fence. So this 200 feet is the perimeter. So perimeter equals 2L plus 2W, which can be rewritten as 200 equals 2L plus 2W. Now, since we want to maximize our area, we need to use this formula here for area. In order to use this formula, let's solve this one for L or W. I'm going to solve it for L. So I have 200 minus 2W equals 2L. Let's divide both sides by 2. And so I have L equals 200 over 2 minus 2W over 2, which is just 100 minus W. Now I can use this area formula. So I have area equals length times width, or in this case, our length is 100 minus W times W. So area equals 100 W minus W squared. Let's go ahead and find the vertex of this parabola. If you notice, this is just a parabola. The number multiplied to the squared term is negative, so I know it's going to be pointing downward, like this. And the vertex on this parabola will be the point where our width gives us a maximum height. So if we can find where this vertex is, we'll know what width maximizes the area of the fencing. Again, that's because the vertex is the maximum height of this parabola. We need to find this maximum point to find out which width will give us a maximum area. A in this case is -1 and B is 100. We don't have a constant, so C is just 0, but we don't need a C. We know that our vertex is going to be at -b over 2a, or 100 divided by 2 times -1, which is -100 over 2 negative, or just 50. So that means we want a width of 50 feet. How can we find the length now? Well, we have this nice formula here that we've already solved for L. So our length is 100 minus 50, which is just 50 feet. That tells me that the garden needs to be enclosed by a 50 by 50 rectangle, so a box technically, a square. 50 by 50 by those dimensions will give us the maximum area. Let's look at part B of example 5. A ball is thrown into the air from the top of a building. Its height in meters above the ground as a function of time in seconds is given by h of t equals -4.9 t squared plus 24t plus 8. How long does it take to reach its maximum height? Let's start by drawing out a quick sketch. So here's h of t, and here is t. This is time in seconds. And here we have height in meters. So where will it be here? Along the vertical axis? That occurs when t equals 0, so at t seconds. And h of 0 is -4.9 times 0 squared plus 24 times 0 plus 8 equals 8. So that would be about here. And we know it's going to go up and then eventually go all the way down and hit the ground. Now, all realistically, our graph is going to stop right here. Our graph will never go lower because once the ball hits the ground, it's not going to go any further below the ground. Now we want to know how long does it take to reach its maximum height. Here is the max height. What does this look like to you? This looks like a vertex. So what this question is asking you is to find the vertex of the parabola. We know this will occur when we have -b over 2a. That's the horizontal value, which in this case is our t. B in this case is 24. Then we multiply by 2 times -4.9, which is a. Now use your calculator to work this out. You end up with something along the lines of 2.448979592, and it just keeps going depending on how many decimal places your calculator shows you. So we know this is at approximately 2.4 seconds. So we can write it will Take approximately 2.4 seconds for this ball to reach the maximum height. And this concludes section 3.2.